This aspect you understood? Hello? Now you see, what is this bulb? What is that bulb that you are talking? This is in general a resistor. Okay. So if you have seen a bulb, the bulb has got something like this. So what is this? This is a piece of wire. So this is made of certain materials called as nichrome or tungsten. So these materials, see, as I told you yesterday or in the previous class, the resistance is equal to rho L by A. I suppose you remember this. Rho stands for what? Resistivity. It is the inherent property of a conductor. Aluminium has got some resistance. See, the same, if I take aluminium of this size, same area, same length, if I pass current here and get the current out there, right, this will offer some resistance, and this is aluminium, so some resistance is offered. Instead of aluminium material same size, if I take silver, it will offer less resistance. Understood? It will offer less resistance. Okay, understood all of you? See, now as human beings, okay, if I try to push you, you will offer some resistance. If I push all of you, each one of you will offer different resistance to my push. Is it clear? Okay. Now this is the characteristic of the materials. So that is what we see. And if the length is more, if I take this of this much length, then the resistance will increase. If the rough road is long enough, then the resistance will increase. Then the cross-sectional area. If the cross-sectional area is more, the resistance is less. I gave an example. See the exit door in your classroom, in your school. Say you are 60 students, the bell rings from the exit door, you all 60 students want to get out of the class. So you all run. Okay, but it will take few seconds for all the students to go out of the class, because the door size is 4 feet. Now supposing I make it 8 feet, then the time for which you exit from the class will reduce by half. So same way, if the area is more, cross-sectional area is more, then the resistance offered by this will be less. So that is something that we have seen here. Hello. Now, in a bulb, this is a piece of wire. The length of the wire is something, the cross-sectional area of the wire, the cross-sectional area of this wire is something, but this material is, say, tungsten. Now the resistivity of tungsten is very, very large. It is very, very large. Okay, so the electrons, the energized electrons have to do a lot of work to overcome the resistance. And when they do lot of work, lot of heat is generated. Lot of heat is generated. And that heat is sufficient to get converted into light energy, and that's how we are getting light energy. So basically a bulb is also a resistance. You appreciate that? There is one element of electrical sciences called resistance, electrical resistance. Is that clear? Hello?
Yes, sir.
Okay. So,
What are the use of resistance?
Good. Now, see, resistance is a necessary evil. Just like friction. The floor needs friction. If there is friction between your feet and the floor, then you can walk. So you need friction. But at the same time, because of the friction, your shoes is getting worn out. The tire of the car is, so many grooves. And then eventually, after 1 or 2 years, you will find that it is like my head, sap. It has got worn out. That is because of friction. So, do you need friction or do you need friction? In one way you say, yes, I want friction. In one way you say, I don't want friction. It's a necessary evil. Okay. Now, if you want lot of electrical energy to be converted into heat energy, then use a element which has got more resistance. For example, you deliberately use nichrome and tungsten in a bulb so that the most of the electrical energy should get converted into heat energy and light energy. And in iron box, you are using nichrome wire because you want to convert electrical energy into heat energy. Okay, but in the wire that you see here, everywhere, I don't want resistance. Why should I heat the wire? In fact, if you heat the wire, it will be fire. So here I don't want the resistance. So I will try to make the wire such that the resistance in that is least. So if you want more heat, then use an element which has got more resistance. Got it? That is one of the uses of resistance. Hello, what did I say? One of the uses of resistance. Okay. Now it's a good question that your friend has asked. Let me elaborate on it.